Alright guys, so today we are going to start talking about combinations, okay? So before we do that, right, you read the little blurb at the top. We'll go back to it in a second. I just asked you guys to answer this little scenario, okay? So there's three friends, Sam, Heather, and Josh, okay? How many different ways can you line up two of them at the water fountain? So what did you guys figure out? How many? Do you guys all agree that it's 6? Right? So, right, it would be Sam, Heather, Heather, Sam. Do you guys agree? Right, because I do want to show you guys all of the scenarios. And then it could be, okay, no, that's good. Because it doesn't matter which ones we do next. So Sam, Josh, and Josh, Sam. And then lastly we have Heather, Josh, and Josh, Heather. Okay. So that, because it's such a small sample space, we can do the visual. But technically, you guys know the math now, that technically, could you have just went 3 permute 2? Would that be the same thing? Right? And you would have also got 6. So we have some background that we don't technically have to write all the scenarios down. We have the math to back it up, so we could have got 6 regardless of writing them all down. But how many different groups of 2 can they form? 3. Right, so there's only 3 groups. Because, I'm just going to rewrite what we just had up there. Do you guys see how then when we build a group, order doesn't matter? Because this right here only counts as a 1. Because Sam and Heather versus Heather and Sam, it's one group, right? Sam, Josh, Josh, Sam, still is only one group that we're creating. And lastly, right, Heather, Josh, and Josh, Heather. Again, order doesn't matter when you're making a group. So it cuts it down, okay? When we do, like when we're lining them up, order matters, right? Because position matters, right? Both positions count in example A, right? Both positions don't count in example B because we're making a group. Hence, on your guys' formula sheet, I'm going to show you something and then we're going to talk about it. So n commute r equals n factorial over n minus r factorial. Does that look familiar? But there's an extra piece. So the extra, what's the extra piece on this formula? R factorial. Guess what that extra divide by r factorial does? Divides out the repeats of groupings. Because when we're doing a group, is this a repeat? Yes, that's a repeat. Is this a repeat? And lastly, is that a repeat? Right? So it cancels, it basically divides out the repeats because with groups, right, order doesn't matter, right? When you're arranging objects, order does matter. So that's what that extra r factorial does for you. It divides out the repetition, okay, of arrangements because we don't care about how they're arranged. We just want a group of 2, group of 3, whatever the case may be. Technically, guys, combinations are way easier, I find, than permutations because I can't give you very many restrictions when I'm making groups. Because does order matter when I make a group? No. Right? So way less restrictions that you have to worry about. The only thing that I can do when I'm making groups of things is like if we're making a group of people, I might say there has to be 2 girls and 4 boys, right? So you will not find yourself ever doing this when you're making groups. Because does order matter when you make groups? No. So if you find yourself doing this in a combination question, stop. Because that tells me order matters, right? Where you're going to put your pen next, right? Even if I start on the far left, I'm still choosing that position to start. Do you guys agree? Where with groups, right, position doesn't matter at all. So for combinations, you're going to find yourself just using this notation a lot, right? Because that notation, so for this question here, guess what the notation would have been? How many people do I have? 3. And I want to make a group of? That's all it is. Right? So that's a combination. So guess what? The formula would look like this. It's still 3 factorial over 3 minus 2 factorial. But remember, if I stopped there, that would get me the 6, right? Which is how many arrangements of 2. So dividing that extra r factorial, does it divide it by half? Or I shouldn't say divide by half, divide by 2, right? It divides it by 2, which is what I needed, because I needed all that bottom line to go away, right? Because those were extra arrangements. They're extra groups. I can't have a JS and a SJ. It's the same grouping. Right? So that's what that extra r factorial in the formula does. Okay. So do you think sometimes I'll ask for a combination question to be written in factorial notation? Yeah, if I do, guess what? You're using the formula to do it, right? Pardon? Right. Yeah, because remember, there's notations that we can do. So 3 choose 2 is the same as 3 factorial over what? Because I wouldn't leave it like that. So that is the same as 3 factorial over 2 factorial. Would you guys agree? Right, because 3 minus 2 is 1, 1 factorial is 1, so that I wouldn't write a 1 factorial. So if it's a combination question, sometimes students get confused if a combination question is written in factorial notation, because normally factorial notation, right, we can see when we lay all our lines out and we start organizing, right, the order. Don't get confused. Combinations can also be written in factorial notation. It's just you're using the formula to do it. Is that making sense what I'm saying? Right? Where you don't have to use the formula to do factorial notation when we're doing permutations, right? Because once we lay all our information out doing permutations, can we see the patterns? Right? So we don't need to use the formula with permutations. We do need to use the formula, okay, to see the factorial notation. All right. So, the other thing I should mention, because I've seen it now on the diploma twice, it didn't ever show up. This is on your formula sheet, guys. And choose R, right, is on your formula sheet. But if you see something like this, right, it's weird notation. IB exam uses it quite a bit. But the 30-1 diploma will use that as well. So just if you see crazy 2 numbers on top of each other like that in brackets, that just means the top number is the number of objects and 5 is the group, right? So you have 7 objects, right? You're finding out how many groups of 5 you can make. Those notations mean the same thing, but it is on your formula sheet, that notation, to remind you that those 2 things do equal each other, right? So I just want to mention it because I don't use it very often, but like I said, I forget which diploma, but I did see it on a diploma as one of the options of true, false scenarios. All right. So again, just shows you the formula. So let's go ahead and see how combination questions will read versus, right, next class, we'll mix them all together. So today we're going to focus on combinations, but on a quiz or a test, are they all going to be intermixed together? Yeah, you'll have to be able to read and comprehend. Does order matter? Am I arranging objects? Okay, versus am I making a group of something? And believe it or not, we're not going to do it today, but do you think there will be a random question where it could have both in one question? It could. That's a standards of excellence question, which I'll show you further down the line. But not hard once you recognize them. Okay. Oh, so example 1. To win the Lotto 649, a person must correctly choose 6 numbers from 1 to 49. Pete began to wonder how many different combinations there were. How many different combinations would Pete have to create to ensure he had the 6 winning numbers? Okay. So with 649, order does not matter, right? If you, because it's a little bubble sheet, you just randomly bubble, right? 6 numbers. As long as those 6 numbers get drawn, you win, right? That's how the pot gets split. Yeah. So if you ever hear on the radio, they are like 5 people won. Like, have you ever heard that before? So yeah, so if more people, like if there's more than 5 people, or there's 5 people that pick the same 6 numbers, and those 6 numbers are the winning numbers, those 6 people, or however many people bubbled the same thing, they split the pot, right? They split the winnings. Right? So with this one, does order matter how you bubble your 6 numbers? The order doesn't matter, right? So how many numbers do you get to choose from? Right? So 1 to 49, so there'd be 49, right? So if it's 0 to 49, there's 50. So there's 49 numbers. You're staring at the little bubble sheet. It's like a little long rectangle. Only reason why I know because my mom plays it all the time. And then I see them laying around, okay? And then you literally look and you just random. Bubble in 6 numbers. We're not going to get into, you can get a bonus now. Anyway, we're just keeping it simple, right? No, because when they draw them, it's like a little barrel and they pick 6. And then you look, did I pick a 6? Yay. Great. No, that isn't how it works. Like everything, when you put your numbers in, it goes into the system. Yeah, no, because everybody would win, right? So when you gamble, guys, is there a recording of what you did? Yeah, so when you bubble your 6 numbers, you have to bubble it in at the gas station or whatever, wherever you got it from. Then you hand the ticket back to the cashier. They put it into their little gambling machine. It's called a whatever, 645. I don't know. I don't do this, so I'm not really perfect. But I have family members that do, right? So then you put your little slip, they put the little slip into the machine. It tallies it, and then you get a spit out of your receipt, right? So that's the receipt that you check. So you have this little piece of paper that recorded everything that you chose. That's why you have to do it before a certain time, right? Because if it's drawn at 7, you can't get one at 6:30 or 6:50, right? So it's recorded, so then you wait, and then they draw all the numbers. And if you miss the draw of the numbers, is that a big deal?
Yeah.
Nope, because it's all in the computers, right? So if you're not sure if you won, then you take that's what people do. You take your little slip back to a gas station. They run it through the machine, and it spits out what you won. Because it's not all or nothing. If you get, I don't know how all the rules work, but if you get 3 numbers, you win some money. Like, again, don't know the rules. But I do know that my brother and my mom sometimes wins $5. I don't know what they match to win $5, but you know what I'm saying? So there is other combinations that could win you some money. But if you match all 6, right? And like I said, there's bonus numbers. I don't know how all that works, right? It's like a big jackpot. And the thing is there going to be some weeks that nobody wins? So guess what happens? Right, it keeps getting bigger and bigger, right? I always get phone calls from my brother. You should get the 649 this week. It's $45 million. Well, no, I know the stats of the chances of me winning, so I don't waste. No, I shouldn't say don't waste my money, because do people win? Yeah, so I could be that lucky winner. But I'm just like, the math is not in my favor. I just can't do it. Well, that's what my brother keeps telling me. Exactly that, right? So anyway, I don't play because I know a little bit of the math. But again, I could win, because is it a lot of it? Is it luck?
Yes.
Absolutely. Okay, but guess what makes gamblers? Thinking they're going to win all the time, and they keep spending more and more money. Okay. Yeah.
What you can do is buy all the tickets.
Oh, we'll talk about that, because that's not realistic. So William just said, why not get all the combinations? Just a minute. So let's actually figure out this number. Okay. So 49, choose 6, right? So if we type that in, 49, so math over to probability, over to probability and number, sorry, I hit the wrong button. Over to probability number 3, 6. All right, so, all right, so there's, yeah, so 983,816, okay? So that's how many different ways you would have to bubble it in if you want to guarantee yourself a winning ticket. And is every ticket $1? No, I think they're like $10 a ticket. I don't even know. So does it make sense that you can guarantee a win? Unless you're a quadrillion million dillionaire. But not really, because will the pot be as much as you spent? No. Right? Yeah, William.
So what I'm saying is like, that's what I'm saying. Like, if you buy all the possible ticket combinations, like that, if that is less than the jackpot amount, you basically just make money.
Oh, for sure.
That's what I mean.
Yeah, but again, exactly.
Okay,
That's the other thing, right? You're not guaranteed that you're going to be the only winner. So that's why, because otherwise, wouldn't people do that all the time? Yeah. Every single system is made up that the 649 company, whatever, is making money. You guys get that. Any gambling institution, they make more money than they lose. Otherwise, they would go out of business. Yeah. Ah, yes.
Yeah, it's either $4 or $6 either not worth it, and I'd say 99% of the time, everyone who wins very little, under $50.
Oh, exactly. It's very, and again, is there a big winner once in a while? So, and isn't there a bonus number too that you could get? Yeah, so I don't know how that all works. Like, well, I think the bonus number is just like, oh, if they pick the bonus number, it's an extra $10 or something. Like, I don't know exactly because I don't know the rules. But it's interesting for sure, right? So very hard, and like I said, every single place where you can win money is set up that more people lose than win. Like, it has to be set up that way. It's all to do with probability and statistics. But again, could you be that one person, that's the stat, and you win $5 million? And you only spent $100 in your lifetime? It could happen. It's just, right? It's just the odds are not in your favor. Yeah, you're good? All right, so again, just kind of neat to look at. So again, over 13 million different ways you could bubble in 6 numbers on that sheet. Crazy, okay? All right, so next kind of scenario, right, is there's 12 females, 18 males in a grade 12 class. The principal wishes to meet with a group of 5 students to discuss graduation. So how many selections are possible? So this would be the case where there's no restrictions, okay? So does it matter female versus male in A? No. So then you just look, how many objects in this situation, students, are there? How many students is he looking at? 30. So there's 30 students, because at the first scenario, male versus female, don't care. So there's 30 students. So 30, and we're choosing 5. Right, so 30, choose 5. So there's 142,506 different groups of 5 the principal could choose. What order does matter? Right, if I just asked how many ways can you line up 4 of the 30 students at a water fountain, Yeah, that would be different, because then that would be 30 commute to 4. All right, so next one, how many selections are possible if the group consists of 2 females and 3 males? So this would be this scenario where I add restrictions, okay? So for here, do them, right? So we deal with the females, and again, it doesn't matter which one you deal with first, males or females. So we need 2 females. So how many females can we choose from? 12. So it would be 12, oopsie. Yep, 12 choose 2. No, right, times, because are we making one group? Right, the only time you'll ever plus is if you're doing different cases, just like we did with permutations. This is one case. So 12 choose 2 times, males now we have 18, and we're choosing 3. Does that make sense, guys? We're multiplying, right? So it's one case, it's one group we're making. Again, the only time you'll add something together is if you make one group of 5 that consists of this many males versus female, and they said, or you can make a different group of 5 with this many males or females, and they want to know total groups. Then you would add those 2 totals together, right? But if you're making one group, do both scenarios, multiply them together. Right, so order does not matter. 2 times 18. Choose 3. Did you guys get 53,856?
Yeah.
856. All right. So next scenario. So one of the females is named Brooklyn. How many 5-member selections consisting of Brooklyn, 1 other female, and 3 males are possible? So are we still making a group of 5? Yes. So what not that you have to write this down, but I'm going to. What guarantees Brooklyn if I wrote it as a symbol or a notation? 1 choose 1. Do you think on the diploma they'll write the 1 choose 1? Probably not. I haven't seen them, but can you guys? I like writing it just so you can see. That right there represents Brooklyn. She's guaranteed, right? So she comes out of the mix because she's guaranteed in the group. She's sitting there waiting for the other 4 to come, okay? So then I need 1 other female. So what is that going to be now? Nice. Do I think the common mistake I have is people do this all the time still? All the time, okay? Brooklyn is no longer in the mix of being in the group of people to choose from because she's already sitting there waiting for the other members. So if somebody's guaranteed, you have to take them away from the rest of the pickings, okay? So they comes out of the females. So 11 choose, 1 more. And then we need 3 more males. We haven't taken any males in the group yet, so we still have 18 to choose from. Right. So if this was a multiple choice, normally they would just write this. Okay. Like I said, I like writing the 1 choose 1 just because then you guys can see the second numbers should all add up to the group number. Right. So, but do I need to type in the 1 choose 1? No. Do I technically have to type in the 11 choose 1? Because what's that going to equal? 11, right? But if you want to, you can. I'm going to actually just grab this. So since it was there anyway, I'm going to, because I'm cheating. So 8,976. Now please make sure, guys, don't get confused, because technically could they write this like this? I'm going to go back up to B just because this is sometimes where students get confused. Sorry, that was loud. On a multiple choice. They might do they might do this to you guys. They might go, it's 12 factorial over 10 factorial, 2 factorial, times 18 factorial over 15 factorial, 3 factorial. Will that be okay if they do that? Don't assume if they write it in factorial notation, it's guaranteed to be a permutation. All they did to do it in this form is use the other side of the formula. And again, would you do that on a quiz? You could, but would you guys? Well, and again, yeah. Like, and to me, just even showing your work, right? If you want to, you can. I'm just saying, don't freak out, right? If the diploma writes the multiple choice that way. Because a lot of times students just assume as soon as they see an answer using factorials, they think it's a permutation. That is not the case, okay? Right? It's just normally we never use that side of the formula unless we're forced to, right? The only time that I would want to use, right, the left-hand side of the formula is if I have an equation I have to solve, right? So if I have an equation and I give you this form, do I have to write it to the other form? Yeah, you have to. Then you have to use the other side of the formula, which we'll do in a minute, okay? But if you're just setting up a question, using the left-hand side, just the C's, way faster, nicer, compact. But like I said, if there's a multiple choice and they wrote it like this, nobody's freaking out. You're still setting it up like that. And then you would look through your multiple choice questions and go, oh, that's not there. What's equivalent? Oh, that's equivalent. That's here, but equivalent. Okay. All right, so let's keep adding some restrictions. So here it says Jason, the principal's son, is in the class and has to be in the group. How many 5-member groups include Jackson? Nope, new question. D is D. D doesn't do anything to do with C. So Jackson's in the group. So what guarantees Jackson? 1 choose, 1. So this guarantees us Jackson. Times, is there any other restriction? No. So we need 4 more group members, right? How many people do we have left to choose from? 29, because we are now putting them all into the same group, right? So we have 29 more students to look at because we took Jackson out because there was 30 and 29, and we're choosing 4 more because it's still a group of 5. So these style of questions, we always start back from the beginning, like the whole, all the people. All the people. New question, all the people. So 29 choose 4. So there would be 23,751. Right, so stop me if I lose anybody. So far we should be good. Oh, fix that. Sorry. All right, so next one says twins. Peter and Sarah are in the class but cannot both be in the group. How many 5-member groups do not include both twins? So guess what we'll do here? Right. Right, so both cannot be in the group. So both of them being in the group is both of them are there. So one can be, the other can be, or none can be. So you could do all the cases or do what Julia just said, like we did last class. Is it easy for us to find how many groups have them in it and then subtract it from the total? That's the fastest, easiest way. Right, so then we would do, so total without any restrictions is 30, choose 5. It's a group of 5. Minus the twins in it. Right, so the twins in it is 2 choose 2. That guarantees, or could you technically go 1 choose 1 times 1 choose 1 to get both twins in it? Yeah, but can't I just do 2 choose 2 guarantees Peter and Sarah. So this guarantees Peter and Sarah times, right, how many leftover students are there? 28. And we're choosing how many more? 3 more. How is that sitting with you guys? 30 choose 5 gives you all the groups of 5s that are possible. Okay. The second scenario is how many groups have Peter and Sarah in the group. So if I take the difference, the leftover will be how many have either one, the other, or none. That's what's left over. So do you guys agree that this is very similar to the case where we're doing, you know, where they can't be beside each other scenario, that idea? Same idea. So So did you guys get 139,230? Right, so E and F, they consider standards of excellence in this chapter. Okay. So last one in this scenario just says there must be at most 2 girls in the 5-member group. So you guys will see at most or at least. Okay, those are the 2 other cases you guys will be asked to do. So if you see an at most or at least, you have to do the cases, right? So at most 2 girls means there could be what? Right, so it could be 0, 1, or 2. So there could be 0 girls. I'm just going to write down the cases. And if there's 0 girls, that means there's 5 boys. That's one case. 1 girl and 4 boys. And lastly, 2 girls and 3 boys. So there's no way around this one. You have to do 3 cases. And guess what you're going to do with those numbers? Once you get case number 1 number, you're going to add it to case number 2 number because it's 3 different cases. So let's do all 3 cases. So was there 18 girls? No, 18 boys. So, and 12 girls. So 12 choose 0 times 18 choose 5. We're going to do that. 12 choose 1 times 18 choose 4. And 12 choose 2 times 18 choose 3. What's 12 choose 0 equal to? 1. So you could not, you don't have to type that in. 18 choose 5. Oh goodness, sorry. 18 choose 5. Thousand 68. Bless you. right, so 99,144. Is that what you guys got? Still typing it in. Hope I typed it in all right. I think I did. I think we're good. Are we good so far? Good, good, good. Kate, do the next one. Did you guys get 300? All right, so with combinations, guys, right, they're usually pretty easy to recognize. Some of them get a little bit confusing. The more, like, definitely look at your diploma questions. But like I said, next class we'll put it together so you can see, because right now you're going to know when you read it that it's a combination question because it's today's lesson, right? But I think when even some of these textbook questions, I think do have it mixed up. I can't remember though. But next class I will mix them all up, right? And we'll look at some together. And then you can start seeing, oh, is this a permutation or a combination? And today, like I said, we'll leave the equation ones till next class, right? So next class, even though you technically, should you be able to do this question now? With the amount of work we did from the permutation formula? Yeah. But like I said, we'll just stick with, do some combination questions. Don't worry about equations yet. But next class we'll do ones where the C is in it instead of the P. It's the same process. You just have that extra little piece. Okay? So that is enough. And I am going to send you home with some more permutation questions that you're going to hand in.